Hi, and welcome to this presentation on soil health. I'm Christy. I'm the agronomy agent here at the Pueblo County Extension Office. Let's get to it. So soil is composed of sand, silt, and clay, and some organic matter. Each component varies greatly from place to place, meaning there could be a spot, a farm field that has a lot of sand in it, and maybe, a little bit down the road, a field that has more clay in it. So soils can range and be quite different from each other. And these differences are going to make productivity in the soil pretty different. Soils do differ in their water holding capacities, which also make a difference in their productivity. But soil is very important. It holds moisture for us. It provides the nutrients which is needed for vegetation and crop growth. It's the main resource for all living life. Within the soil matrix, sand, silt, and clay particles come together to form aggregates, often also called PEDs. These aggregates form little holes all put together, and these little holes are called pore spaces. And this is where air and water can infiltrate. If we look at our pie diagram over here, we've got the mineral particles, that's sand, silt, and clay. And we've got our organic matter, that's all of the living microbes in the soil, all of the roots, dead or living, and then all of the humus, which is mostly decomposing organic matter. And there's that space for air and water. It makes up the entire soil matrix. Soil is also defined into lateral zones, which we call horizons. The top horizon usually is named this topsoil, right? And basically this is where most of the activity occurs. This is where living roots are. This is where the nutrients is. This is where the microbes are, where the organic matter is. Each horizon, as you go further down, has less and less activity. By the time you get to the deep into the soil, it's mostly just the inorganic components of the soil, sand, silt, and clay, probably some rocks thrown in there as well. Typically, we see less and less activity deeper and deeper in the soil because there's less and less oxygen. Most life needs oxygen to live. And so without any kind of oxygen, roots can't grow, microbes can't decompose organic matter. And so we see less and less activity the deeper we go into soils. Soil health is becoming a widely discussed topic. Scientists and farmers alike are gaining a better understanding of soil and how this natural resource must be cared for in just the same way as we care for trees and water. Soil provides food energy for the people and helps to purify water, along with many other benefits. Like I said, it's one of the most important resources we have, and all life depends on it. According to Columbia Climate School and their State of the Planet, we're seeing that a majority of the soils in the United States are degraded or very degraded. And 66% of that degradation is caused by agriculture, whether it be farming, growing different crops, or raising livestock, rangeland, pasture land, whatever it happens to be. How can we slow the process of degradation, and how does that benefit us? We like to think that healthy soil equals a healthy bottom line. Oftentimes, healthy soils use less energy or require less energy input. You might not have to take the tractor across the field as many times, not put in as much labor. If you don't have to spray weeds constantly, you might not have to pay somebody to do labor for you. Less inputs if you're not spraying fertilizer and pesticides constantly. Purchasing those things typically means a little more money in your pocket. And oftentimes healthier soils do tend to provide higher yields in crops. So all done well, Healthy soils should equal a healthy profit. Today we're going to discuss 4 of the overarching main soil health principles, and we'll get one extra in there. This one is kind of an up-and-coming principle in becoming more and more integrated into soil health. We'll discuss biodiversity, continuous living roots, various soil cover, and minimal disturbance, finishing off with adaptive grazing. Biodiversity refers to the variety of plants, animals, and microorganisms above and below the soil that interact with ecosystems. This is a major tenet of sustainable agriculture. We want to mimic kind of the natural habitats we see in a natural ecosystem, that there are tons of different plants and tons of different wildlife and tons of different things and activities going on. Oftentimes we find our farm fields with monoculture. We'll see corn planted in the same field year after year after year, which is not very diverse. So we want to expand the number, the types, the differences in the plants that we're planting, in the insects that we're attracting, in the soil microbes that we are bringing in. We thank University of Arizona Cooperative Extension of Navajo County for this information on biodiversity. So when we're also thinking about biodiversity, we have to think about crop diversity, crop rotation, intercropping, cover cropping, conservation tillage, and incorporation of organic matter. These are all important components for farm biodiversity. We want to talk about biodiversity in plants and animals. We just discussed using different crops, rotating crops, putting different crops in the same place so that we're not having some sort of monoculture, but we also want to integrate some sort of animal life, livestock. You can graze your cows on your cover crop or graze your cows in your field after it's all done. One thing to also think about possibly are those little critters who like to dig under the soil. We don't often like them because they eat our roots, which is not good for production, but they do bring oxygen down to the root level, and their little poops also bring some sort of nutrients once that gets broken down. So got to take the good with the bad, I suppose. Productive, healthy soil is more than just dirt. It's living, breathing, dynamic ecosystem. It contains billions and billions of organisms all over the place, and the health of the soil and all it produces depends on these organisms. It's just most of the microbiotic community living in and on the human body. The vast majority of these organisms are beneficial. So most of the organisms living in the soil are not pathogenic. They're not going to cause crop diseases. They're not going to cause decrease in production. Alternately, they typically help and increase yield and increase production. And then we can think about organisms in the soil as microorganisms and macroorganisms. The fungus over here on the right is going to be a microorganism. That's something we need to look at with a microscope. And then we've got macroorganisms. That's going to be our arthropods and our earthworms, like the little guy over here in the left. For our soil microbes and macrobes, we've got bacteria, which often are decomposers and help to recycle nitrogen. Main source of nitrogen fixers are some bacteria. And we've got our fungus, mycorrhizae fungus is going to be one of the most important root symbiotic relationships in the plant world. This fungus can help the plants to get more water, get more nutrients, gather it up, and mutualistically, the plant provides the fungus with some sugar, with some glucose. That's the fungus's food, and the fungus helps the plant out. Then we also got protozoa. Protozoa help with nutrient recycling. Nematodes, those guys are good. Some of them are bad, but a lot of them are good. They can eat the bad guys, do some more nutrient cycling, getting that nutrients available for the plants back into the soil. And then we've got our larger guys, the arthropods and the earthworms, and they're going to be our shredders and decomposers. They're going to make all of that big stuff small so that the bacteria can actually work on it. One might ask, can the good microbes really outcompete the bad microbes? Well, yeah, with the right conditions and in the right setting, the pathogenic bacteria don't have a chance. Um, Plants send out signals to various fungus and bacteria that say, hey, I want to be in a relationship. And the good bacteria and fungus respond, and they help the plant to become stronger, more vigorous, which fends off plant pathogens. Roots you might say, are what holds it all together, literally and figuratively. They are some of the most important components within the soil matrix. Roots, and having a living root in your soil for as long through the year as you possibly can also helps the microbes, because that's basically their home. So having a living root in the soil keeps those microbes going without having the microbes to go dormant for long periods of time. Roots create exudates for microbes. Once they've got a symbiotic relationship, they'll feed the microbes. They'll be the home for the microbes. Sometimes microbes invade into the roots mutualistically and get food from the plant, but also gather nutrients and water for the plant. Roots help microorganisms build soil aggregates. We'll discuss soil aggregates in just a bit. But soil aggregates are super important to have, and this is going to be all done by roots. And then just inherently, a root's job is to gather water and nutrients for the upper part of the plant. Next soil principle is minimizing bare ground. You can do this in a variety of ways. You can use a cover crop, or you can mulch the ground, leave crop residue. Oftentimes, that's sometimes the easiest thing to do. You may think of other things you can do so that your ground isn't bare. A tilled field with bare ground is prone to erosion, especially from wind here in this area. So leaving your ground bare oftentimes results in loss of that topsoil, loss of that nutrient layer, which requires more input from the farmer the next year. Cover crops can be a bit contested, especially in a specialty crop system. So let's discuss some disadvantages and some advantages of using a cover crop. Disadvantages might be something like using our initial inputs are really high. It's very intense, a lot of work to get a cover crop going. And then on top of that, it takes a really long time to see results. You don't see results within the first 2 to 3 years. It takes, a good 5 years before the cover crop is established and you're actually seeing good soil health from cover crops. It takes extra water. It takes extra water to water that cover crop. And if water is lacking, which it often is, not really an easy thing to just make water out of thin air. So one thing to consider that. It can make planting more difficult. It's hard to get through that crop residue, or you end up having to purchase really expensive equipment to make it happen. Oftentimes cover crops have to be terminated. So if something survives through the winter, if you do fall cover cropping, you'll have to kill it before you can plant your cash crop in the spring. And there's not necessarily enough research being conducted on using cover crops in specialty crop systems. Tomato and pepper seeds are pretty delicate and need a good seed bed to actually get growing. And cover crops could potentially hinder that. So more research needs to be conducted on whether that's a viable option. Some advantages, though, of cover crops, they do help to reduce compaction. As the name suggests, they keep that soil covered, and then they can be used for forage. It's actually a really good way to kind of counterbalance having to feed your livestock hay all winter long, is if you can stick your cows on a field with some cover crop and they can just munch on that all winter long. Kind of helps in that respect. Does provide a living root longer and throughout the rest of the year. That way those soil microbes continue to do their job, making the soil healthier. Does help in soil aggregation, preserves some soil moisture, and does help in nutrient cycling. Next principle, minimizing disturbance, minimizing tillage in the soil. So if you think about the soil matrix as the home of the microbes, and the microbes are doing a lot of work cycling nutrients, making it available for plants, building those soil aggregates, building those PEDs. Every time you till, you basically knock the home down of every single microbe. It stresses the microbes out and they go into a dormant state. And in that dormant state, they're not doing anything for your soil. And your soil is pretty well just not working at all, which requires more input from the farmer. If you don't have a soil microbe making nutrients available, the farmer has to put the nutrients in, which often results in more expense, more input, more time, more labor. So we till, however, to prepare the seedbed, to reduce seed pressure, and to bury our leftover crop residue, right? It's going to decompose faster if it's buried and under the ground. Unfortunately, that's not always the best thing to do. It can lead to erosion, tilling can, especially, like I said, in our area from wind. And so we often see dry, cracked earth, or if it were to rain ever, we might see some water erosion runoff, and then we'd get potentially some compacted soils running our equipment through that wet soil. We're going to go back real quick. So if we were to not till and we were to allow the soil to form more aggregates and just hang out, our soil pores would remain, so water would infiltrate better. Soil aggregates would not be destroyed. The homes of the microbes wouldn't be destroyed. The soil food web would increase, so we'd get more diverse microorganisms in the soil. We wouldn't bring up new weed seed every time we till. So every time we till, we bring up new weed seed ready to germinate and start being pesty again. We'll be able to capture water and store it. And then our soil fungi and earthworms will increase. All right, on to soil aggregation. Soil aggregates or soil PEDs, the chunky portions that we're looking at here in these pictures. Basically, it's the byproducts of the bacteria and the fungus and the exudates from the plants that kind of come together and form like a glue that sticks the sand, silt, and the clay particles together, basically. So that's what we're seeing with soil PEDs. This is the superior matrix for nutrient cycling. So we think about it like this: if there's less surface area for nutrients to stick to the soil PEDs, that means there's more nutrients that's available for the plants. And also creates more soil pores for water and air infiltration into the soil. So as we saw in the previous picture, bare soil is very prone to losses due to water erosion because the water, if it were to rain, water drops would bounce off, run off, and disturb the soil and the crop residue. But crop residue, however, can capture the water and pull it down into the soil. So we're looking at these pictures here and we can see the soil PEDs, those aggregates. The larger the aggregates, the more easily water can infiltrate through and down the soil matrix. Oftentimes soil texture does play a role. We know that water moves through sand pretty quickly and not quite as quickly through clay. So it's essential and extra important to have good aggregation in your soil if your soil is more of a clay soil. That way water can still get in and penetrate through. Here we're looking at a little diagram showing water infiltration in various forms of cropping systems. We're seeing the most water infiltration with a cover cropping system and in a perennial system. This basically means that we've got living roots constantly, right? And those living roots are allowing the microbes to make more aggregates deeper and deeper into the soil, which allows more and more water and air infiltration deeper and deeper into the soil, as opposed to conventional farming. Last note on soil here with regards to tilling is soil compaction. Oftentimes a major issue caused mostly by heavy equipment on wet soils. Every time you drive over a wet soil with a piece of equipment, it squishes those soil pores together, and so we lose that space. Every time we plow, we can start to form what's called a plow pan. Basically, we till up to a certain depth, and past that depth, there's an impermeable layer where we don't get down further into the soil horizons. And that can be limiting to roots as well. Compaction just in general reduces root growth and water infiltration. Things we can do to kind of remedy that. Some tilling, sometimes if it's so intense and you're in a hurry, tilling might be the only option to reduce compaction. Oftentimes growing tuber vegetables, things like daikon radish or beets, things that are going to kind of make the soil expand and break up, will help to revert compaction a little bit. Cover crops actually do help and aid in decompacting some soils because of those living roots constantly in there and the soil microbes working on making good and true aggregates. Oftentimes a cover crop can help in so much as that it acts as kind of a cushion and takes the weight of the heavy equipment driving over, as opposed to transferring that weight to the soil matrix and causing more compaction. And our last note here, grazing livestock, basically grazing livestock on your cover crop does have some benefits, does help the soil somewhat, get some of that excess residue out of there, helps to mix the nutrients back into the soil. The movement of the hooves and the movement of the livestock's feet kind of mushes and squishes soil and different organisms back into the soil, deeper into the soil. That's a great source of fertilizer. And it can also be economically beneficial, as mentioned earlier, if you don't have to purchase hay and feed for your livestock through the winter, and they can just nibble on cover crop through the winter. One less thing to have to pay, one less thing to have to worry about. Last slide, last thing here to note, some different resources that we've got. USDA NRCS soil specialists, especially here in Colorado, and some and the specialist in New Mexico. Lots of great resources from those guys. And then also some great resources from CSU as well on soil and soil health. If you have any questions, feel free to give the extension office here in Pueblo County a call. We'd be happy to help you with any soil health questions you might possibly have, or if you're just looking for more information on how to get started into soil health. Really appreciate you guys listening to this presentation. Thanks and have a good day.